So, welcome back to VTU e-Shikshana program on computer aided engineering drawing. We are in model 3 discussing development of surfaces. Today let me take the very critical, it is simple but it is very critical, pentagonal solids, particularly pentagonal pyramids, wherein the true length plays main role. In all cases true length plays main role, but here identification of true lengths of corresponding distances, particularly truncated solids, it is very important. Now let me take 2 to 3 problems now and discuss. One is the pentagon with one base edge perpendicular to VP, and one base edge is inclined at 45 degree to VP, and one more is the typical problem on hexagonal pyramid. Now let us observe this particular figure. Here a pentagonal pyramid is cut by a section plane inclined at 45 degree to HP, inclined at 45 degree to HP and passing through the midpoint of the axis. Say axis say 60 mm. Then what about midpoint? Midpoint is actually 30 mm from the base or from the apex. If they give specific distance like 15 mm from the top end or apex etc., you have to take accordingly, otherwise normally they give bisecting the axis. So you know how to draw the top view. See, one of the base edge is perpendicular to VP, draw the top view, and in pyramids it is very interesting and also very important to note that VA, VB, VC, VD and all visible if the section plane is not taken. But in case of development we are not much bothered about the top view. Whenever we want true length then only we take it, otherwise also in light lines only you have to join all these points and keep it ready. Okay, that is what. Unlike prisms you only to identify the axis point, that is midpoint of the surface. Here you have to address the slant edges VA, VB, VB, VC etc. Now corresponding distances, you take the height from the axis and identify V, join all corners with this A dash, B dash, C dash, D dash, E dash. Then cut this. Once you complete the section plane as per the requirement, then dark the required remaining portion of the solid. Okay. Remaining portion of the solid is very important, because based on that only we are going to mark the intersection points with the section plane and the edges. Here only slant edges are interacting with the section plane. Okay. So identify the points of intersection. Here VA is intersecting at 1, VB is intersecting at 2, VC is intersecting at 3. Only one edge. Here there are 2 edges, one you can see from the front and one back side, that is for D, VD, it is 4. Then similar to VB, VD, we are VA, VE 5 dash. So these are the points of intersection with the section plane. How to draw the development for this? Before drawing development we should see whether the true length is available for the slant edges. See, here whenever I draw the development of pentagon 1, 2, 3, 4, 5, okay, it is for the hexagon, and if it is for pentagon it is for hexagon. Now 1, 2, 3, 4, 5, this is slant edge true length and this is the base edge length. Now what you have to do is start from a line that you know V, and also A, start from A to B, B to C, C to D and D to E, again A to A, E to A. So this is how you draw it. Now let me do that. Before that, true length is available or not? Now this is very important line for me. VC is parallel to XY line. Definitely V dash C dash is true length. If not, then you never get true. For example, in this case you take none of the lines are parallel to XY line. None of the lines are parallel to XY, because this line, one of the base edge is inclined at 45 degree and this is slightly away from the parallel line, and this also like that. Suppose if you have the orientation, one of the base edge is perpendicular to parallel to VP. In this case also you never get any of the line parallel to XY line. So, in this case also you have to find the true length, that I will discuss in computer, only selected items are worked out here. Now, after this let me take the true length reference. True length is available, that means now let me conclude V dash C dash is true length in this case, since VC is parallel to XY line, parallel to XY, V dash C dash is true length. That is what we concluded. Now, you take this distance. So, okay, let me take this and assume that it is L, small l. Normally, we take this as L. Okay. L equal to radius, draw an arc with a selected point. Normally, I have sufficient space here, say I can draw the arc, big arc, okay, like this, then mark the points. Okay. So, here start from VA, that is true length L, draw an arc, then mark points 1, 2, 3, 4, 5, it is extra. Now, join this. What is this length? That is base length 30. Okay. Now, join them carefully, join the respective points with V of X. This is development, complete development of the required, overall development of the required solid latter surface 1, 2, 3, 4, 5. Okay. So, here is A, B, C, D, E, again A. Next comes the points of intersection we have located. How to get these points of intersection? We must project all these points onto true length line. In some cases, none of these lines may be true length, so you will get extra line, that you know, already we worked out some problems. Now, this one you project, this one you project. In case of cone also same thing. So, here is 1, 5 true length V1, V5, instead of taking this you have to take. Here is 2, 3 axis line, it is not a problem, here is one more, this is 2, 4. You can keep 1 dash etc., not necessary. Here 3, that itself is the true length, 3 dash. Okay. Now, start working. If you want to take the true length of V1, V5, you take from this, not from this. This is apparent length, this is true length. Draw parallel to the base, that is very important. Okay. So, mark this point, distances. Yes. This is how you draw the development. Okay. Now, you identify how much is this, you can computer, you can identify this dimensioning one by one, taking individual line and mark it. So, here dimensioning is very important. After dimensioning, after drawing the development, this is 30 and this is L. How much you are getting, that automatically you get, your if it is manually you write how much it is. Okay. That is all about the development of this. Now, let me come to this point. Problem is here the orientation of the pentagon itself is neither the corner condition or edge condition. In case of solids, we do that. In that case, even in corner condition you get it, edge condition, either both the sides you get, but here it is different. Now, let me identify section plane, again here bisecting the axis and the section plane inclined at some angle. You now identify, okay, axis height, or otherwise how much they give you can take accordingly. So, this is 35 then, bisecting the axis, 45 degree or whatever the angle they give. Basically, we have to find out the true length here, because none of the lines are parallel. Now normally we take to the right side either VD you take or VC. Let me take VC only. C1, I am anticipating C1 dash there, C1 dash. Whenever a line is inclined to both the planes, for example, let me take this way, inclined to both the planes, this is V, this is C, say C dash, okay, here other way around, this is V dash, this is C dash, this is VC. These are the final views of VC. How to find the true length? You make it parallel, so project it onto the moving locus, then join it. This is VC, V1 dash, VC, V1. Definitely you get the true length. Same way we are doing it. C dash, join this and this. Okay, this is the true length. Okay, after joining this, you have to draw horizontal lines from all the points of intersection. Before that, let me dark the portion which is retained after taking section. This one, and again here is dotted line for E is not visible. This is for C. Again this is for D. Okay, now join them. Base is always dark. Identify the points of intersection. 1 dash, 2 dash, here we cannot mark now, this is 3 dash, 4 dash, here is 5 dash. Because 5 slant edges are there, it is interacting only with the slant edges, so only 5 points you get, here also 5 points. Suppose that it intersects the base, then only problem starts. You have to work out accordingly. Now, including 4, you have to draw horizontal lines, 4, 3 very close lines, 5, 2, here no question of coinciding of lines here, all 5 lines are at different points. This is for 1, this is for 2, this is for 5, this is 3, this one is 4. All are on the true length lines identification. If you want to take V2, you take from V2 like that, okay, mark. Then let me check for the place. Okay. Assume that I have a space here and then mark here 5 points. Then this is VA, then VB, VC, VD, VA again. Join them in order. What is the distance? True length. V dash C dash is true length here also. So that is equal to L. L equal to radius, draw an arc. Okay. Then take base distance, say base distance is 30. Base distance is 30. 30 equal to radius, draw arc. Then join them. Okay. 5 points. 1, 2, 3, 4, 5. So this is B, C, D, E, A. All with light lines. L equal to radius, draw arcs. Next, take individually distances one by one. Don't mix. Majority of the time what happens, instead of 1 we take it for 2, VC, VD, etc. We can do carefully. You have to take V to A, V to A. Between V to A we have 1. Take this distance, maximum distance is here. This is 1. Take true length and mark. Manually it is easy. Take compass and keep it here. Post it here. Next V, that is V2. Then 3. 3 is on VC. Again 4. 4 is on VD. Yes. True lengths only on this line. Then 5. 5 is this point. next comes 1 again, same distance you will take it here. So, even though it is simple, it must be carefully worked out and then present 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, and then join this remaining edges. And sometimes I observed people keep curved line only, no chance, it is only straight lines, you must join them without any missing. So, no curve business, it is only straight lines because all are edges. So, this is the way you work for the development of truncated solid. In truncated solids, always the points of intersection, whether it cuts the base or only the slant edges, are very important. This is how you do it. So, I will work out one more problem in computer with the same series with one base edge is parallel to VP, then we will see that. So, finally, let me take this particular pyramid, and this is not conventional section plane, it is what some design. Okay. For example, a particular work needs that type of design. So, what exactly we need to do? So, now what I do is I will cut this solid for a particular height like this. I want only this portion. I want only this portion. What to do? Or one may say, why not this side? Yes, you can work out that also. Let me work out this first. What about this type of development? Now, I will develop here, okay, because I have space, sufficient space here. Before that, let me check what exactly these intersection points. Unlike previous problems, we use this symbol convention for that. Here also you can use it, but not necessary. They give the question itself like that. Now, points of intersection is this one, that is not exactly the edge, we do not have any edge, it is at the mid portion, mid line of the, because it is true shape, not the true shape, this one is true length, in fact this is true length, this is inclined actually. So, whenever you take this, this is inclined, but exactly at the midline you have that point, okay, that we will locate. Okay. Next, this is 2, that is between VC, then VD we have 3 dash, VE we have 4, then again same point here back side. Okay. Suppose that you cut this at this way, in this way, exactly same point will be there back side also. Okay. So, that one we are identifying 5 dash in bracket, 4 dash also in bracket. Okay. So, what exactly true length, is it available? Yes, absolutely, the true lengths are available because VA or VD both are parallel, both lines are giving you true length. But here I never use the measurement concept from point to point. Suppose that you have the section like this throughout, what you will get? You will get frustum of cone. For that, what you do? Frustum of cone, you take, in case of cone also, you take this equal to radius L1, this is L1, L1 equal to radius, this is L, total L, L1 equal to radius, draw an arc. Then suppose that this is the development 1, 2, 3, 4, 5, 6, yeah. Then you simply draw this one, okay, that is all. Then join all points with lines, okay, okay, 1, 2, 3, 4, 5, 6, then this is the frustum of hexagonal pyramid, yes. Now, you just check all these points lying on this arc only the difference is the respective edges. Okay, let us try here only, they will do separately. Okay, try here. Say this is A, B, C, D, E, F A. Okay. Now, the intersection I have taken L1 say and marked this arc and joined. Okay. See here it is 1 is, let us leave 1 and 5, afterwards we will take, then 2, 4 and 5. Okay. That is 2 on C, okay, 2 on C. Next 5 on D, then okay, A 2, 1, 2, 3, 4, 5, yes. This is 1, this is somewhere here you will get 1, this is 2, this one is 3, okay, this is 4, somewhere you will get 5. Okay. So, I can identify 2, 3, 4 on the arc intersecting the edges, but how to mark 1 and 5? So, let us see how it works. Then let me have a choice here. Yeah. Okay. Now, let me draw an arc 1, 2, 3, 4, 5, 6. Yes. Then join. Okay. Now, take L1 equal radius, draw arc. Then name A, B, C, D, E, F, A. Okay. Now, what exactly the position of 1 and 5? 1 and 5 is actually you have to bisect this BC, there only you get 1. Not exactly on the intersection of arc, but we have to draw a line, you have to draw a line and then that line is intersecting with that particular bisector line, then you will get that as 1. See here also same thing, back side between E and F, yeah, E and F you have the same thing, draw line, then whatever the intersection line, mean bisector line gets you 5, 1 and 5. 1 and 5 are critical points now. Next, as usual, you take this as 2, this is 3, this is 4, that is all. Now, you join these points. You have to remove these points. This is like a specific pocket. Yeah. Now, these things V2 2, V2 3, V2 4 are not part of development, they have to be removed. Only the remaining lines are to be made it dark. Now, let us see VA, yes, then VB is completely available. Okay. Now, we are intersecting with the section plane, yes. Then 2 to C is available, 3 to D is available, 4 to E is available, yes. And again this line is completely available, VF, last VA again it is available. Then join this with lines. Okay. Now, key points are 1 and 5. See, this is 1 that is not on any edges, that is on the bisector of this sector. Again 5 is on the bisector of sector and intersection with the bisector and line joined between these 2 points, as though it is the frustum of cone. We draw the arc. See, this is the arc you have, this is L1. Now, these are the 2 points of reference, you join this, then this is the bisector. This becomes the critical point. Now, this is 1 that side, it is, this is between BC and that one is between EF, that is all. So, this is how you can complete this. Suppose that somebody wants the same thing here, same type, you have the reference 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Okay. Now, let me name A, B, C, D, E, F, A. Now, draw this again. Naming is different now. Different means that is not this part, it is different points. Let me complete this as usual. Instead of right point to be removed, left point to be removed, that is all. Now see this one, let it be light lines. Okay. Now start naming points of intersection. This is to be retained completely, this is to be removed. Now name it accordingly. This is 1 dash, that is between VA, 1 VA, then VB we have 2, then mid portion of this sector we had 3, exactly back side not visible 4, this one is 5, that is all. Now let me start working. This is 1 on VA, okay, 2 on VB, then this is 3. How to get 3? Same concept. You have this line and between this point and this point you draw a line and this line. This point is the 3, not the arc point, okay, not this point. This point is the point of reference. Next, dark this. One to 2, 2 to B. You are not supposed to join 3 to the end point. No end, no corner there. Just keep like this. Yes, that's all. Next, that side also you get same thing. Now join remaining portion of VC. This one is also unaffected, and E, that C, this is E. E is also not affected. Then F, just observe here, this point is 4. This point is 4, not the arc point, line joining this and this, 4. Again, this is 5, this is 1. Now join this. So instead of mid portion, you get the other portion. Now, where is 5? 4 is this, yes. This is available, completely available. This is completely available. Part of this portion, removed portion here, and part of the removed portion here. It is in only one place. Something like you have the development 1 piece, 2 piece. It is not like development 1 piece and 2 piece. The removed portion at the 2 places. Here removed portion at only 1 place. Okay. So if you work, you will get clear idea. Anyway, the same thing I will try to explore in the computer. So let us work a problem on pentagonal pyramid for the development chapter. Here we have a pentagonal pyramid of 30 mm base edges and height 60 mm as its base on HP, such that the base edge is perpendicular to VP. So you can see this the base edge is perpendicular to VP. Next, it is cut by a section plane inclined at 45 degree to HP and bisecting the axis. See, here it is 60, and if you measure this, definitely you will get 30. Okay, and because of computer will give the symptom midpoint, then automatically you can go for that particular point. You will not measure, okay, directly you can do. Okay, if you want, you can measure also. Now the development of the lateral face of the face containing the base, portion containing the base. Sometimes they may ask you portion containing the apex also. That type of problems also I will do it in future. Now basically you have to know what exactly the concept is. That is why I took this type of problems. Majority of the time people commit mistake. So VC is parallel, the slant edge VC is parallel to VP. Definitely VC is V dash C dash is true length. Okay, if you measure, you will get around 65.09. Okay, for the same thing in your computer it may be small, second decimal place may be changed. Okay, or it may be 65 exact. Now if you do the calculation, then only you will get pakka value. Okay, next, the edge condition, and correspondingly this VC is there. In solid only we say edge condition, corner condition. Here this is specific position, location, You have to identify the orientation and mark it, that is all, no question of inclination. So, that is why you must be very careful. If you commit mistake in this, then everything will be gone. Now, after taking the true length, okay, that is 65, you can start working for the development. You know how to draw the development of the cone and pyramids. You can create this, triangle first, take 65 and then draw an arc, then draw only this line, then catch this triangle, go to mirror and then go on continuing this till you require till you get the required number of this, then stop. So, assuming that you know the work of this, how to work here, this is A only. Yes. Now, the section plane is inclined at 45 degree, then identify the portion which is retained after taking section, then start naming. This is 1 dash, 2 dash, 3 dash, again here we have 4 dash and 5 dash. So, after getting these 5 points of intersection, then you project onto the true length line. Since you already concluded that this is the true length of VC, definitely you can identify the points on that. Then measure one by one and then post it on to the true length line. Say on VA, we have V1, 1 is here. So, you take the true length here, not here, this is apparent length, except this all other lines are apparent length. So, that is why we have projected here parallel to the base, not horizontal. Simply you say horizontal, in any other position it is different, but parallel to the base you have to project. Here normally base is on the ground, definitely parallel to HP. Now, after projecting and identifying these points, you get what I have done. I have drawn a full arc to cover both the points. Otherwise, you draw here arc, one more arc here, that is enough, because again here it is easy for me. VB and VD are same distance 2, 4. So, it is same arc. Then 3 is independent. Okay. 5 is also on the same arc, that is 1, 5, 1. So, that is why I have drawn arc and then join 1 to 2, 2 to 3, 3 to 4, 4 to 5 and 5 to 1. You will get the profile of the development. Next, if you want the portion containing the apex, you have to dark these edges. Normally, by default, you have to do this. If nothing is asked, remaining portion of the solid after taking section. That means arrow refers to you retain the portion below this arrow. That means you have to draw development of the remaining portion. Now, draw all boundary lines dark, then the edges which are starting from the intersection points are to be marked dark lines, because they are going to retain of taking section. Okay. Now, this is what the development is. So, here the criticality of the problem is identifying the true length. If it is available, you make use of it and then carefully post all the distances, particularly development. In development, true lengths only you have to do it, because if you keep it on a flat surface, you will get true lengths. Suppose that if you take this and then do it, you never get the model of required shape and size, you will get something different. Okay. Now, here is the problem with same problem with one base edge is inclined at some degree to HP, that is all. One base edge is inclined at some degree to HP, same wordings, see here. Okay. Now, here none of the lines are parallel to VP. So, that is why what I did, I took D. You can take C also, no problem, any slanted, all are equal. Then project it and go up, you will get D1 dash, join that with C, that gets you true length 65.2. It is almost same size is there, irrespective of orientation you get same true length. Okay. Now, after drawing in the section plane, you try to dark the remaining portion. Here the little confusion is there here, I will tell you what confusion. Very close lines are there. See here the because of inclination C and D and true length all are there. You must be carefully with patience you should do it. This is 1, this one is 2 and E you should not give right now. Then you have to give for C, then D, then E. okay, similar to the one which I worked out, okay, same type. Next comes the development. You know how to draw the development. A, start from A, B, C, D, and then catch these distances carefully one by one, check twice. Here what I have drawn the arc, individual arcs, because all are different. No 2 or 3 slanted edges are taking same distances like before. Okay, here it is only the single references. So that's why I have drawn arc. Or you can do one thing, you can take line reference, draw up to that, and then I have extra small line, then that is the indication. End of the line you can take for the joining. So whichever is best suitable for you, you can do it. Now after doing this, you try to join all of them. You will get little bit symmetry here. Okay. So the thing is they are not actually same distance, even otherwise you will get something like this, join this. So suppose again here if you want the portion containing the apex, you dark this, otherwise this. Now join all those points. Normally people end up with this, they join simply boundary and then say this is answer. No, you have to join all these 2C, 4D, 5E, etc. That is actually representing the slant edges, remaining portion. Next comes the one more problem I have taken. Here I told you this is the base edge parallel to VP. In this case also you never get true length, because none of the lines are parallel. For that what I did, I took VC as a reference and then rotated about CV, then got this is C1, yes, this is C1 dash you get, okay, C1 dash. Better name it because the procedure, okay. So here is the C1, this is C1, this one is C1 dash, the corresponding point on the moving locus, C1 dash. So this is C1 dash, okay. Now that is true length, okay. See around 65 you get. Now the thing is, take the true length equal to radius, draw arc, then base distance for 30, same procedure, no change, irrespective of the orientation, the overall development is same, because you keep it on a flat surface. If you close it, you will get pentagon only. Only thing is, while keeping the base, in which position you have to keep, based on that you have to do it, that is all. Now after doing this, you take the intersection points. You just observe here, I have darkened the portion containing the apex. That is what the requirement, dark the portion containing the apex, because they need development portion containing the apex. So definitely you have to do like this, dark the portion, okay. That is why I have not put arrow here. So just you can draw a line, in fact, in that case, okay. Now name the points of intersection, identify this, then get the profile. This portion only you have to dark, okay. Suppose that if you keep the portion containing the base, then you will get 2-piece development, it will cut here, then no gap, still there is no area there. That is why this one piece, this becomes another piece, but on paper it is single, having C as common. Otherwise if you do like that, you will get 2-piece only. Then dark this and then identify this, dark the portion containing the apex. So this portion is to be removed, okay. This is how you identify the development of surfaces of particularly pentagonal pyramid with care you have to do it. See here I have all the lines identified, true lengths, and the very close lines are there. You must be very careful, and with patience you must work. Now let me take hexagon pyramid, and I am interested to remove this portion for a given height, okay. So this height may be, they specify accordingly, you do it. Sometimes it is bisecting, otherwise yes, bisecting, just 30 is there. So they give this figure, okay, this particular figure they give, and having the boundary line dark, okay, because that and also the edges retained to be dark, okay. Now only this portion VC and VE and also VD are losing some portions because of this section plane, two section planes, one vertical and other one is horizontal. Okay, now how to carry out? Already explained. So here the unusual point, not on the what is called slant edges, it is on slant surface, but luckily it is on a symmetrical line. You can easily identify how you bisect this. That is between BC, you bisect BVC and then draw a line with the arc intersecting there with L1 as center. That point, see, this point is 1, not this. Okay, so this is very important. This point is 1. Similarly, in this case, this point is 5, the one which is on the straight line and one more radial line. Okay, so this is 5, not the one which is on the arc. So here, this is 2, 3, 4. What? Here is the clarity. VC is having 2, VC is having 2, VD is having 3, and you will not take individual distances. Okay, anyway, as though you are projected onto the true length line, since this true length line you are getting. That's why we simply draw an arc throughout, complete. Then wherever you want, we select. Then criticality of this problem is key points 1 and 5. Okay, so how to identify? Bisect this, again bisect BVC and EVF. Definitely that gives you these points. That is on imaginary line, midline, and again this is midline. Okay, then dark only up to this and then complete. Okay, so what are to be completed? See, this one, this is this side I have taken. Now dark only the required portion. So what is that? V to 1. This is V. This is V. V to 1 you have to dark. Select the dark line. Okay, for explanation purpose I may take little more. This is select line. Select line and dark lines. Yes. Now start with this. Again, this line is to be dark. Yes. This line to be dark. Yes. This is not complete. This is for portion. Yeah, this is to be dark. Yes. This is also dark. Base edges dark. Yes. Dark that. Yes, purposely I am taking 70.70. Okay. So you see that this line is dark. V C. VC is V2 1, V2 2, 3, 4, V2 yes 3 to 4, 4 to 5. That's all. Again back to V. So this is the pocket where you cannot dark this, but less other than this boundary you cannot dark. Again this one must be dark. Is no way connected with intersection. Again this is no way connected with intersection. And what about this 4E? Yes. And 5 to this line you cannot dark because this is only imaginary line. And 3 to D, yes, because this is actual edge. And 2 to C, actual edge. And this one you cannot, don't dark it. So this is as usual, dark line is there. So this is how you dark the development. This is the development. Except this portion, all remaining lines are available. Okay. If there is any confusion, you can remove this R to avoid any confusion. Remove this R totally. If you want to retain, you retain. See, now, and also you can trim this, but let it be there because this is in light line. Okay. Now, if the things are other way around, see, this is what I have done. Okay. Suppose that the things are other way around, what to do? This side. Here, one is on VA, again one is on VA, then V5 and 2 are on VB and VF, then 3 and 4 on midlines. Okay. So, how to do it? Then, after concluding drawing this, you dark this portion. Yes, 70. This one, and up to 3. Then go to V. Yeah, then some problem is there. Join. Do one thing. Let us draw first line, complete line, joining this and this thin line. Then identify the point. 3. Yeah, 3 is this point, not this one, not on the R, this one. Okay. So, here now I select the line suppose I select this line, this is completely available. Okay. Dark this is 0.7. Yes. Now start working on the lines. Start working on the lines. You can overwrite. This is, yeah. Okay, what is this? Select these lines. You will get style. You identify that with 0.7, 0.5 actually, 0.5. That's all. You will get 0.7. So if it is independently done, okay. Otherwise, you can overwrite. Line style is this 7. Draw. Yes. 2 to 3 is here. This is the problem. We have here is this 1 to 3. Yes. Then draw. Because this cut portion, even though it is the imaginary line, this is cut portion, you have to dark that line, not this one. Okay, next, this line is available completely. VD is available and VE is available. From 4 again you have to start. See, yeah. Now this is 4. This is 4. Now take this line command, already we are in line command. Then change it to 0.7. Start this. 4 to 5. Again 5 to 1. Solve. Then see that this line is dark. Again 5 to F is dark. Then V to E is dark. It is unaffected by the section plane. V to D is also dark. Again this is free from section plane. Now that's all. See, this portion and this portion is to be removed. All other lines are dark. Okay, these lines are, if you feel that these lines are extra for you, you can trim. That is only for procedure. You retain this portion also, you can let it be there because this shows the procedure. You have joined and identify this. Say, this is how you can keep left portion it is removed and here is right portion is removed. So, this is how you can work problems on development. So, any problem on development, you see that the true length is available. If true length is not available, you identify the true length and project on the true length if it is pyramid. Okay, and then take it. In case of prisms, if you get any top face and base intersected by the section plane, then you see that whether true length is available in top view or front view, and accordingly you work. Okay, so now we will see in further sessions work problems on development or any other chapter. Thank you.